Good morning, Bears. It is kickoff lesson. It is thermal energy week number 2, transfer of energy, molecules, kinetic energy. What is going on with heat? How is that school going to get heated? What about the parents' concerns about that water is just not warm enough? Remember, we got a big bunch of water below the school, or we have a smaller amount of water that's hotter, and which one's going to heat the school better? We're trying to solve that problem. As you can see with our slide, a lot of these circles to represent molecules, air conditioners, so we can learn from our lesson. Remember, you can now change this title slide, call it whatever you want. Instead of at-home lesson, you might put by Leroy or something like that. You can put your own pictures. Always make a good title slide. Remember, Science Week's, a lot of it's pre-done for us, and we're going to walk through the plan. So let's take a look at what's going on. Remember, this just tells you what to do. Check groups daily. Make sure you do all your Mandy's. This reminds you how to write a CER, claim, evidence, reasoning. FIST essay works for CERs. FIST essay works for stories. FIST essay works for cause and effect essays, informational essays, persuasive essays. So the FIST essay is a good tip to remind you how to write clean essays. Let's get to our lesson. Remember, we have been thinking about this question: why do molecules change speed? The purpose of today's lesson is to answer the investigation question by choosing a claim. You'll collect evidence from 2 sources. We know a lot about sources from history to help you evaluate these claims and choose one. So by the end of today's lesson, you will see in groups, you're going to choose one of these claims. Let's go review our groups basics. Monday, thermal transfer of energy. Lesson 1, slides through 125. We're going to try to get through lesson 1 today, Monday. It's going to be tight, but we're going to do it. Play with sim. See slide 7 for details. Remember, 7 could change if you add a slide. Play with sim. See slide 7 for details, but I'm going to walk you through it right now. So if you're watching this video, you don't worry about that. Close read article, paragraphs 5 through 7. Find corroborating evidence that matches the sim, that supports what you learned in the sim. We're going to go play with the sim on this video. It is ideal for you to click the link provided down below and play with the sim yourself. But if you don't, for some reason, or you get to this later, or the sim doesn't work, just watch the video and learn. I'm going to give you time in Zoom to play with the sim. We'll read the article together, and then you're going to create a top claim slide. Pick which claim is correct, place evidence from the article, copy and paste, and evidence from the sim. That's your own words. You have to describe the observations to write a CER if you're A level. All right, let's get back to the slides. So we have these 2 claims. 1, molecules speed up when energy is created, and it slows down when energy is destroyed. Claim number 2, molecules speed up when they get energy from other molecules and slow down when they give energy to other molecules. Let's take a look at the evidence. First, you'll add or remove energy from samples in the sim and use the view kinetic energy toggle and the view energy transfer toggle to observe what happens. We're going to do that together now. I want you to go play with it, but watch me do it first, just as a little overview. If you're watching from home, this slide around 7, if you haven't changed anything, you can click sim. You can make this bigger to read it better, remember, and if you need to see things, and this walks you through the process. So it says launch sim, add 2 samples, view kinetic energy toggle, view energy transfer toggle, and change the temperature. We're going to do that together right now. Let's dive into it. So once again, you have to log in. The link is in groups. It's also in the slideshow. First, you add a sample. We want the same size samples. Let's go for small. You can do whatever you want, and there's fun things you can do later. Let's add another sample, small, confirm. Now we have 2 samples next to each other. Notice they're the same. Now, remember what it said: view kinetic energy, view energy transfer, and now we're going to play with it. But before we do, if we put these together now, let's just see what happens. 30, 25, 30, 25. Nothing happening. Interesting. Bring them apart. I'm going to make the right one hot. And I like to go even numbers. It won't get me go too even. Let's try to get something close. Thermal energy 105. Well, just remember 30 to 105, temperature 25 to 93. So we have thermal energy and temperature. They're close here. 105 and 93. So there's a relation. 105 a little bit bigger than 93, 30 a little bit bigger than 25. So that's one thing we want to look at. Notice the thermal kinetic energy is more yellow, high. Energy transfer, we don't see anything going on now. So now what the sim said is we're going to move these two together, but we want to have analyze. So see this button up here? You can't see it on the screen, but it's over here. You click analyze. So now when we do this, I thought it would work as together, but it doesn't. So let's get out of analyze, go back to run. First we'll bring them together and then we'll click analyze. Now let's watch what happens here. High, low. Dun, dun, dun. Ta-da! Interesting. It says view energy transfer, and that's that arrow. So it's showing us 68 is going down. Interesting. They stabilized. And we saw the higher energy moved into the lower energy. Now let's analyze. And we see over time. So we had our sample A is represented by purple, sample B is represented by green. You can't see it on the video here, but it's there. And they were together, and then look what happened. They came to be the same. So they were parallel lines, and they became the same. Interesting. So what can we learn from that? Go play with the sim a little bit. See if you can duplicate my findings and see what you're learning from this sim play. I'm going to give you I'll give you 3 to 5 minutes. 5 minutes. Go play with the sim now. Played with the sim. Let's see if we can figure out what we've learned here. Record your evidence. And remember, your evidence is observational, so you have to write your own words here. You can't just copy and paste. Now, scientists often collect evidence from multiple sources to make the strongest argument in support and claim. We do this all the time in history. Corroboration. You'll reread part of the air conditioner article to gather more evidence. Sophisticated readers reread text to better understand difficult ideas. Reading more than one also builds something called persistence. Persistence means sticking with something even though it might be difficult. This is a good tip. We're going to read the 5th, 6th, 7th paragraphs. Your goal is to continue to gather evidence about why molecules change speed. So we're going to go to the article and we're going to read this. And we're going to see here it said, because remember we have two claims. Molecules speed up when energy is created and slow down when energy is destroyed. Or is it claim 2? Molecules speed up when they get energy from other molecules and slow down when they give energy to other molecules. So we have evidence from the sim that might be giving you an idea for claim 1 and 2. Let's back that up from the article. Let's go read it now. So this paragraph 5, 6, and 7, we're looking for evidence that supports what you saw in the sim. What is happening with energy transfer? So look for sentences, could be an image, because we're going to make a corroboration claim slide on which claim is right, and you need evidence from here. So let's go ahead and read this again. It starts at 2:30. If you're watching this video at home, you can go open the link or just read along with it right now with me. Here we go.
So applies to hot foreheads. Have you ever been sick with a fever and wished you could do something to feel better? When you have a fever, one way to feel some relief is to soak a washcloth in cool water and lay it across your forehead. Some of the energy from your warm skin transfers to the cool cloth. When two things of different temperature come into contact, the warmer one will always transfer energy to the cooler one. In this case, your warm forehead transfers energy to the cool washcloth. How does that transfer actually happen? Since we know what happens to molecules when matter changes temperature, we can infer that the molecules collide with one another as they move. At the moment of collision, energy transfers from the molecule with more kinetic energy to the molecule with less. The fast-moving molecules of your hot forehead bump into the slow-moving molecules of the washcloth, transferring kinetic energy from your forehead to the washcloth. Your skin cools as the molecules of your forehead slow down. while the washcloth gets warmer as its molecules speed up. You can think of your forehead and the washcloth as two parts of the same system. Energy is transferred from one part of the system, your forehead, to another, the damp washcloth. As the temperature of your forehead drops, you feel better. However, that same washcloth won't keep you cool forever. Eventually, so much energy will transfer from your forehead to the washcloth that the washcloth and your forehead will be the same temperature, and energy will stop transferring away from your forehead. When that happens, it's time to get a new cool washcloth so that this energy transfer can keep going and you can keep getting relief. Whether you are cooling a room or your forehead, you need to transfer energy to do it. When one thing cools down, something else has to warm up. Since energy can't be created or destroyed, a change in temperature always means energy has been transferred. It always comes from somewhere and goes somewhere else.
Okay, so that's great stuff. I saw a lot of it supporting evidence, including right here at the end. Now remember, just a little tip, you do not have to do this, but if you ever want help writing a CER, and they'll probably give you these tools on the test you're going to take. You open this up, you highlight it, then you take a note. And so remember, this is your evidence. We have a claim we're trying to support. This evidence supports your claim, and then you have R for reasoning. And if you put your reasoning here, this evidence supports my observations in the sim. No molecules left, they just slowed down while the others sped up. So what you did right here is you did a little reasoning corroborating this evidence with your sim observational evidence. When you go to write your CER, you just have to organize your thoughts. You put this into a quote. You put this after the quote. Maybe you give another example. Then you write your conclusion. And you have a nice fist essay with a claim, evidence, more evidence, because this is talking about the sim, and your reasoning, and a conclusion sentence, and you have your CER. All right, so we just walked through the process. Let's go back to our sim. Once again, you can play with this again. There's different things we're going to do with it later. And let's continue on to the final. That is the final thing. I just explained what we're going to do. You're comparing the two: evidence from the article, evidence from the sim. I had put it in the video. Now, which claim do you think is best supported by the evidence you've gathered? Which pieces of evidence support your claim? Claim number one: molecules speed up when energy is created and slow down when energy is destroyed. Do you think that could be it? Claim number two: molecules speed up when they get energy from other molecules and slow down when they give energy to other molecules. It seems to be obvious which claim is true. Evidence supports one strongly. And you have your sim and you have your article. Now we go create a top slide. Don't forget to move your concept slides to the top. So collision, you can move to the top. If you have extra time during the week, you can decorate it, do what you want. Don't worry about the sim. You can observe similar transfer of kinetic energy through collisions between familiar objects. The bat is swinging. There's energy from the body. It hits the ball. It gives energy to the ball, and the ball takes off. That's kinetic energy. So energy transfer, here's another concept you want to move to the top. And here we have our claim number two. Just in case you hadn't figured it out yet, it is correct. But you need to organize it into a nice top slide. So the evidence we have gathered is consistent with claim number two, which states that energy moves from molecule to molecule, but not consistent with claim one because the evidence shows you cannot destroy energy. So what's your final part of the lesson? A little bit big for a Monday, but we got to get it done. Create top claim slide. Pick which claim is correct. Place evidence from article, copy and paste, and evidence from sim, your own analysis based on observations. And that's all you have to do is just put the evidence in. Say what you saw in the sim, copy and paste one piece of evidence from the article, and you're done. That's B level. A level is turn it into a CER, top slide. What's C level? Make those concept slides look nice with pictures. Transfers at the top with pictures, collisions at the top with pictures, and you can have C level in a Zoom every day. You could probably still have a B in class. All right, let's get going. I know it's a lot for a short day Monday, but we can do it. Have a great day. See you tomorrow.